there's our cosine law. Do you see that it looks really similar to a squared plus b squared equals c squared? But it has some extra crap at the end. Because a squared plus b squared equals c squared only works with right angle triangles. Here is what we have to do if it's not a right angle triangle. And you guys just came up with the two situations. Sometimes side angle side, or sorry, side side side. That's when the three pieces of information you're given are all three sides. You cannot use the sine law. The sine law is our preferred law. We'd like to use it whenever possible because it makes life easier. Because it's really easy to see if you have an angle and an opposite side, boom, I can use the sine law, and it's really easy to set up. This is the one situation, and the other situation is when you have two sides, but the angle is in between them. So we call this side angle side. Can't use the sine law because we don't know that other side. We can't find that other side because you're not allowed to use a squared plus b squared equals c squared. These are the situations where we use the cosine law. We also learned last time with the sine law as long as these three letters are different, A, B, sine, C. So the angle I have here is C. I guess this would be A and B, so this makes this little a and this makes this little b. So in this situation where we can't use the sine law, we can still figure out the area. And we actually developed that area formula when we were developing the sine law. But in this situation, how do you find the area of this triangle? Well, area of a triangle, like this is the very first area of a triangle that you ever had, right? 1/2 base times height, or base times height divided by 2. That was your very first area of a triangle that you learned. Now we've added this one because we replaced the height with a b sine c. We did that in last lesson. But there is an area formula for the side one. And it looks like this. The square root of s times s minus a times s minus b times s minus c, where s is the semi-perimeter of the triangle. If you add up all the sides, does that make sense that that's a perimeter? The semi-perimeter is half of the perimeter. So if you were to add, in this example right here, the semi-perimeter would be 5 plus 6 plus 7, which is 18 divided by 2 equals 9. And apparently, if this formula is correct, the area of that triangle is 9 times 9 minus one of the sides, 4, 9 minus the other side, 3, 9 minus the other side, 2, and the area of that triangle is the square root of 36, 72, 260, apparently. So, we have a new area formula. Is that area formula also on your formula sheet? Yes, it is. And it even gives you the semi-perimeter part. So if you're asked to find the area of a triangle now, you have options. Most of you will go hey, find the area of this triangle. Where's your brain going to go to first? 1/2 base times height. Then you're going to be like, ooh, I don't have the height. So you could either spend time trying to find the height, or you could say, I have a new formula that involves an angle. Perfect. And then there are going to be sometimes, ooh, I don't have an angle. Well, now we have a third formula for finding the area. And this formula for me, just a quick, like, did I tell you about the hypothetical, I want a hypothetical milkshake? I didn't tell you the story yet, right? I said, so because of this formula, I won a hypothetical milkshake in university. Because one time my university professor said, oh, here it's sometimes called Heron's formula. Here's Heron's formula for finding the area. If anybody by next class can write up a proof of why this works, I'll buy them a milkshake. So I've got it, I still have it, it's right here on the side of my filing cabinet. It took a couple hours, I worked on it, I figured it out, I handed it in, and it was the most disappointing thing ever. Professor, I was like, all right, gonna go for a milkshake, this would be awesome. He was like, here's a tune, go buy yourself a milkshake. You know, if you're gonna do that, right, actually take the kid out for the milkshake, or change it and say, I'll give a toonie to every billion on them. They're like, yeah, I'm not gonna do that. So I did it for the milkshake. So that's why I call the fact that I want a hypothetical milkshake for coming up with why this proof works. And I have it right here. So
if we come up with why it works, will you get us a milkshake?
Well, that's the problem is now there's like AI and stuff like that. It'd be like, did you come up with this? Did you sit in it, right? And I don't think as a teacher I'm allowed to just say, okay, but I have to lock you in a room for the next 24 hours. And if you come out of that room with the proof, then yes. But I don't know if I haven't checked my contract if I'm allowed to lock up students or not. But I'm thinking it's a no. Just gut feeling right now. All right, so here's our cosine law, and these are the situations that we want to use it. And a lot of people like trigonometry because if you recognize the right thing to do, it's just using a formula and some algebra skills, and it makes it really easy to solve. On your test, this is the process I want you to go through every time you see a triangle question. Is it a right angle triangle? First, because then I can use grade 10 math. SOHCAHTOA, a squared plus b squared equals c squared. Look at A. Right angle triangle? No. Sometimes they draw it where, ooh, it sure looks like it could be, but can we assume that it's perfect? No. Unless they put a little box in there that shows that it's 9 degrees, not a right angle triangle. Step 2. If it's not a right angle triangle, go to your sine law first. Do I have an angle and an opposite side? Or could I find the other that so that it could work? I have an angle. Do I have its opposite side? No. This, in fact, is the side angle side situation with an angle smushed between two sides. This tells us we have to use the cosine law. Now I'm going to write out the cosine law again, and just like the sine law, you are going to ignore the letters. The letters are important, but they're A, B's, and C's, and this has got P, R, and Q. I was going to read it out, but it sounded bad. So, I'm going to write out the formula. The formula says c squared equals a squared plus b squared minus 2ab sine c. And I'm going to tell you that the important thing is not the letters, but the following. Whatever angle you have has to go with the side over here. That's the key thing. Just like sine law, angles went with opposite sides. Cosine law has that as well. Whatever angle you're using, the opposite side goes here. So in our question, we want to find Q to R, which a couple of things you could do. You could either call this, because it's opposite of the angle P, as little p. And so if this is the angle that we're using, its opposite side is little p, that's what goes on the outside. The other two sides, it doesn't matter which one you do. Which one's A, which one's B, doesn't matter, because if you add them, can you see this could have been B squared plus A squared. If you multiply them, it's AB, but it could have been baby. BA, there, right? It could have been either way, no matter which way for multiplying or for adding. So the A and the B doesn't matter which ones they are. The key thing is that this goes with this. So when setting up my equation, I have those highlighted. I know that on this side I'm going to have the P squared, and the very end of this, I'm going to have the cos of 31 degrees. I just pick one side to be my first side, and the other one to be my second side. -2, I pick the one to be my first, and the other one to be my second. So plugging these into the formula can be, oh, it's 17. Thank you. So what did I do wrong? That looks like a, there we go. There is a nice 17. Here's another nice 17. So it doesn't matter the 10 and the 17, what order you put them in. The key thing is that when we're dealing with this 31, if that's the angle we're putting in over here, we have this equation. Also, maybe we should write this in your box that has the cosine law. Go back to that. Your formula sheet is really nice to you. No, that's not the box. Those are here, isn't it? Yes. Okay. In this same box that you have the cosine law, I would like you to write the following, and I want to write it exactly. We'll steal your formula sheet for a second. Just to have the letters the same as, yeah, they have C by itself. Mathematically, does it make sense that if you wanted to, you could move things around to get that by itself? And they have done this for you on your formula sheet, which makes your life a lot easier. So the cosine law has two formulas. We generally use this one. We use this version to find a side, and we use this version to find an angle. Because the angle is already by itself, the side is already by itself. And again, the letters are not going to matter. The key thing is if this is the angle that you're using, its opposite side is the one that's getting subtracted. Very important. Other than that, the other two sides, the A and the B, doesn't matter which one you pick for which. But it's very important that sides go with opposite angles. So if you're finding a side, you can only find the side opposite the angle you're given. If you're finding an angle, you have to subtract the opposite side here. The other ones don't matter. Okay, so going back to our first question here. We're finding the side, and the beautiful thing about this is you can type this whole thing into your calculator all at once. So I would do that. I would write 10 squared plus 17 squared minus 2 times 10. And you can either use brackets or you can do times in between. Cos of 31 degrees. You can type that in all at once. 97.563. No other work needs to be shown. Okay? I'm going to just, I'm going to put the plus or minus there and stroke it out. Because when you square root both sides, you're supposed to plus or minus, right? And I want you to think about that every single time. Because it's a number one mistake that keeps coming back. And I think part of the mistake is that over time, sometimes teachers skip it when it's not needed. Like in this case, we're going to find P. P can't be negative. It's the side of a triangle. It has to be positive. So you'll often see like videos online. Where's my calculator? Oh, there we go. You'll see videos online where they just go, and then you square root all of that answer, and you get positive 9.877. And the teacher skips the plus or minus. And so you get into a habit of sometimes skipping the plus or minus, and then when it's important not to skip it, you skip it. And then it comes back to bite you. So I'm going to say it could be plus or minus, but it's only going to be the positive one. We're supposed to round to the nearest tenth, so I'm going to read this. P equals 9.9, and make sure we include our units in the end. So that's A. B is exactly the same. Okay, they want us to find Q to R, so I'm going to put a little P here because it's opposite angle P. It's not a right angle triangle. I don't have an angle and an opposite side. I can't use sine law, so I have to use cosine law. And if I want to find P, this is the angle. Those are the things that P squared equals, and the cos of that angle has to be on the other side, and then it doesn't matter. 10 squared. Oh, this is nice. Look at these numbers are the same. You know why this is nice? If I go to my calculator, you see how I typed this in already once? If I highlight it and push enter, it retypes it for me. What's the only thing I have to change? I just have to change that angle to 131, right? That saved me a lot of time. 612.06. So I have now P squared equals 612.06. Dot, dot, dot. P equals. Right, plus or minus. I'm going to stroke it out. Because we're going to only get the positive value. I go back to my calculator. I square root that number, push enter. 24 point, and I already know what we want to round to. 24.7 centimeters. Circle questions 3, 4, and 6.